Hey everyone, welcome back to another CIE A Level Physics past paper video. Today we're going to talk about paper 1, variant 1.4 from the May-June 2025 series. So let's jump into the paper. Question number 1. The number of atoms in a mobile phone handset may be estimated by dividing the approximate volume of the handset by the approximate volume of an atom. Right, okay. So, an atom is a spherical structure, but the diameter, we know that it's in the order of 10 raised to power 10 meters. So that means the volume would be in the order of, like, the cube of that diameter, right? Because you have 4 over 3 pi r cubed, and r is d over 2 basically. So we don't need the exact value, but we just need it in that order. So if you don't know how we got from minus 10 to minus 30, you just cube it, and using the laws of indices, this becomes minus 30 meter cubed. Then next up is we need the volume of a handset. So some facts which you already must know, that the recent phones that we get, usually about 6 inch, so you can convert 6 inch into centimeters, so 6 times by 2.54, sorry, 4, you get 15, let's say 15 centimeters, so 0.14 meters. The aspect ratio that we get is 29 or 21:9 these days. You can also try it with 16:9 also, but the modern cell phones have 20:9 or 21:9. Either way, this is just the ratio of the two sides. This means that you can find out the angle. So tan inverse of 9 over 20, 24, and what would be 9 over 21? 23. So roughly you can say 24 degrees. Okay, so now you can find the sizes compared to that. So 0.15 sine of 24, that is just simply 0.06, and cosine of that would get us 137, right? Wait, sorry, what was the sine one again? Actually, we don't need it. We don't need it. The thickness is usually like in the order of centimeters, like 1 centimeter, let's call it, which is basically like 0.01 centimeter. Oh, sorry, 0.01 meters. So to find out the volume, we just need to multiply these things. So 0.15 squared. Because we have 0.15 sine 24 and then multiplied by 0.15 cos of that angle, and then 0.01. So you see, we get this answer. Now we just need to divide this by the approximate volume of handset, which is 10 raised to power minus 30. So as you can see, we're getting in the order of 10 raised to power 25. Now, had we used the 4 over 3 pi r cubed, that might have been slightly different. Okay, so for example, if we do that over here, 4 pi divided by 3 times by this cubed. Actually, we did not need that. Diameter cubed divided by 2 cubed, which is 8. See, 26. So the order 26, 25 that we had is closest to this one. So B would be the right answer. Which unit is not equivalent to the unit of energy? Newton meter force times by displacement, that is work. Volt coulomb, that is also energy, that is VQ. ws power time. This is mass times by acceleration, so that is just force. So D is the right answer. Calipers are used to determine the thickness of the wall of the glass tube. The following measurements are made. Internal diameter, external diameter. What is the thickness of the wall of the tube? Okay. So the students, where they made the mistake most was that they just divided the external diameter from the, they just subtracted the internal diameter from the external diameter and they just called it a day. However, if you notice over here, the difference between them includes twice the thickness. So we need to divide by 2. And the same would apply on the absolute uncertainty, okay? So thickness would be 12 minus 10 divided by 2 plus minus 0.1 plus 0.1 divided by 2. So the divided by 2 is basically applied on both of these. Okay. The difference is just 12 minus 10 plus 0.2, but then when you find the thickness by dividing the entire 2, the divided by 2 would be applied on both of them. So you get a reason why is that the divided by 2 on this happens because we need the percentage uncertainty the same. So the percentage uncertainty would remain the same for both of them. Okay. All right. So not for this, for thickness. Okay. For thickness and the difference, because thickness is the difference divided by 2, so they will have the same percentage uncertainty. So that's why we divide by 2. Right, so 2 plus minus, 2 divided by 2, 1 plus minus 0.1. So that is the answer. Okay. The diagram shows two fixed pins Y and Z. The length of elastic is stretched between Y and Z around pin X, which is attached to a trolley. X is at the center of the trolley. Trolley is to be propelled in the direction P at right angles to YZ. Tension in the elastic is 4 newtons. What is the force accelerating the trolley in the direction when the trolley is released? Okay. So if the total length between Y and Z is 80, so the half of that would be 40 millimeters. So since we need the components of tension towards the direction of P, we will need this angle. Okay. So to find out this angle, you would do sine theta is equal to 4 over 5, because 40 over 50 is just 4 over 5. To find out the adjacent one, 4, 5, we can just use the Pythagoras theorem. This is just basic trigonometry over here. 25 minus 16, that would be 3. So cos of theta would be just 3 over 5. Now this tension and this tension, when they added up, this becomes 2t cos of theta. So the total force would be 2 times by force times by 3 over 5. So you get 2 times by 4 times by, divided by 5, 4.8. The student cycles uphill from home to a shop, taking 10 minutes. The student then spends 5 minutes in a shop before cycling home downhill at twice the initial speed. Okay. So let's examine what this means. So 5 minutes in the shop, that means he's at rest. At twice the initial speed, that would mean that he's covering the same distance in half the time. Okay, because the distance from shop to the home is the same. So the distance covered is same, but half the time. So that's what we have to figure this out. Which graph could show the variation of the time of the distance traveled by the students? Now notice that this is distance, not displacement. So anywhere where we're getting distance equal to 0 will be discarded. Now for this one, half the speed, twice the speed would mean half the time. So over here this is twice the time, so obviously this would be correct, because now you see over here 10 minutes, 5 minutes, 5 minutes at rest, and the gradient is twice the first one. That's it. A ball is released from rest from a window at a height of 12 meters above the ground. Air resistance is negligible. What is the time taken after release of the ball for the ball to reach the ground? Okay. So the distance covered by the ball, or displacement covered by the ball, is 12 meters. It's starting from rest. We don't know the final velocity, but we just need to figure out the time. So we can use the half at squared, in this case gt squared. So you have 2 times by s divided by 9.81, and then square root of the answer. This is your time, 1.56, which is 1.6. Which word equation is not correct? Okay, force change in momentum. This is not correct, because force is rate of change of momentum, or change in momentum over time. So this is the incorrect one. A skydiver is falling vertically with terminal velocity when their parachutes open fully. So skydiver is already falling with terminal velocity, that means already constant velocity. And when the parachute opens fully, the velocity will decrease. Which statement describes the motion of the skydiver for the first few seconds after the parachute opens fully? Okay, so if you remember the graph for this, so for example, this would be the terminal velocity, and when the parachute opens, it would suddenly drop like this. And it would then continue at a lower terminal velocity. So this was not supposed to be a straight line. This is supposed to be a very sharp decrease. So this is a very sharp decrease. So for the first few seconds after the parachute opens fully, decreasing speed, so that means this goes. It cannot be uniform acceleration, because the net force has changed. Net force is changing. Okay, so non-uniform acceleration. Two gliders are traveling towards each other on a horizontal air track. Glider P has mass 0.3 kgs and is moving with constant speed of 1.2 meters per second. Glider Q has mass 0.6 kgs and is moving with a constant speed of 1.8 meters per second. Gliders have a perfectly elastic collision. What are the speeds of the two gliders after the collision? Okay. Now, since this is a perfectly elastic collision, we know that the momentum before the collision will be equal to momentum after the collision. The kinetic energy, total kinetic energy, will be the same. MQ UQ squared equals to half MP VP whole squared and half MQ VQ whole squared. Now this also tells us, one more thing, that the relative speed of approach is equal to relative speed of separation. If you want it in terms of velocity, relative velocity of approach is equal to negative of relative velocity of separation. Okay, alright. So one more thing from the momentum and kinetic energy equations, that the momentum and the kinetic energy of the system cannot increase. That would be against the law physics. So the kinetic energy could decrease, but since this is a perfectly elastic collision, kinetic energy total is the same. Okay. Now, since this is a perfectly elastic collision, the relative speed between them will stay the same. So, relative velocity, if you consider between P and Q, so you will have Vp minus Vq because they're traveling in the opposite direction. Okay, and since it's a perfectly elastic collision, their relative speed of approach would also be similar. Okay, so relative velocity of approach, this is 1.2 minus 1.8. So this is your if you reduce the minus, this is the relative speed of separation, or this is the approach, this is the separation. So this is 1.2 plus 1.8, 3. So wherever we get the difference 3, that will be the correct ones. So 1.2, see, the directions will still be opposite. So when you add these speeds, you should get the same difference. Because you see, because of the difference in directions, we actually ended up adding them. So you will, for when you have the speeds, you will actually be adding them up. So 1.2, 0.6 incorrect, 2, 1.4 incorrect, 2.8, 0.2, that is correct, 3.6, 0.6, that is also correct, but let's see which one of them is correct. Okay, so based on the speeds, this is correct, but if you think about it in terms of the total kinetic energy and the total momentum, it would be different. So what if we figure out the total kinetic energy? So total kinetic energy cannot increase. Okay, so this is 0.03. If we make it in terms of kinetic energy, so 0.3 half times by 0.3 times by 1.2 squared plus half times by 0.6 times by 1.8 squared. So this is your total kinetic energy. So times by 0.3 times by 1.2 whole squared plus 0.5 times by 0.6 times by 1.8 whole squared. So this is 1.188 joules. Now the total kinetic energy for the correct option would also match. So if we just swap out with the 2.8 and the 0.2, that is the same. Okay, so kinetic energy before initial is that kinetic energy final. What if we test out with this? If we test out with 3.6 over here and 0.6 over here, the kinetic energy has increased. So this is not possible. Okay. Alright. Which statement about a couple is correct? It acts to produce both translational motion and rotation. No, it will only produce rotation. It acts to produce rotation only. That is correct. A picture frame hangs from a string. The string is supported by a pin. The frame is in equilibrium. Which statement shows the vector triangle of forces acting on the picture frame? Okay, so we know the directions of forces acting on the pin and the string. The tension is acting this way, and there will be a reaction force to these forces, tension forces, upwards. So the triangle of forces will be closed loop, so you will have this thing, and this thing. So this kind of thing. Reaction force is upwards. A solid metal cuboid of density 2700 kg per meter cube has sides of length this. Cuboid can be placed on a horizontal surface so that it rests on any one of the 6 faces. What is the largest pressure that the cuboid can exert on the surface due to its weight when it rests on one of its 6 faces? Okay. So we need to figure out which, to find out the largest pressure. Force is the same. Force is basically equal to weight, mg. Okay. This would be the mass rho v g. Okay. We can actually find out right away. So 2700, 1 times by 2 times by 4 times by 9.81. Okay, we'll calculate that in a second. Cross-sectional area. For the largest pressure, we will have to choose the smallest cross-sectional area. So the choices for the cross-sectional area are 2 by 4, 2 by 1, and 4 by 1. So this is 8 meters squared, this is 2 meters squared, this is 4 meters squared. So obviously this will give us the largest force. So when you do the divided by area, 2 times by 1, so obviously you can cancel these out, times by 4 times by 9.81, this is 105, 948, so that means 105 kilopascals D. Okay, alright. A cylindrical iceberg of height h floats in seawater. The top of the iceberg is at a height h above the surface of the water. The density of ice is rho 1 and the density of seawater is rho w. What is the height h of the iceberg above the seawater? Okay, so we know the equilibrium condition over here, that the weight is equal to the upthrust. So rho v g, the ice density, total volume of ice, that means the mg part of that, is equal to the upthrust, that is rho v g, but this is the displaced of water, volume of water displaced, that means the water fraction of the volume that is in under water, and g is the same. So that means g, when you cancel out, you get this. So you have rho I over rho W. This is a volume of water, volume of ice. So this is not the volume of water, this is just the volume of water displaced by the ice. That means the volume of the ice that is under the surface. So volume of ice it's a cylindrical, so pi r squared h, total h, right? But the volume of the water that is displacing it is pi r squared h minus h. Okay, so that's what we need to write for that. The pi r squared will get cancelled, so you just have h minus h over h. Okay, the ratio, like if you do the ratio over here, pi r squared will just cancel. Just flip the fraction and you will get that. Okay, we need the height h. So first off, we multiply this thing multiplies with this thing. So rho I over rho W h is equal to h minus h. So then you bring h on this side, so this becomes h 1 minus rho I over rho W. This would be A. In which situation the work is the work done on an object? Object slides with constant velocity along a horizontal frictionless surface in a vacuum. No. Okay. Person holds the object at arm's length at a fixed height above the ground. Holds it, so that means there is nothing, like no displacement. Person pushes the object up a frictionless ramp. Okay, alright. Stationary object floats partially submerged in water. So there's nothing, no distance displacement over here. So this is gone and this is gone. Now, the confusion with this is that it slides with constant velocity along a horizontal frictionless surface. So like it's going this way. In a vacuum, that means no resistive, no air resistance, no friction. So that means it's sliding with constant velocity. That means there is no force. There is no resultant force in this. Okay, so no resultant force. That means this is going to be correct, but why? Pushes the object up a frictionless ramp. So although there is no friction, there is no work done against friction, but there is work done against gravity. So that is going to be C. An electric motor operating a lift has an output power of 20 kilowatt. Okay, the lift and the passengers have a combined mass of 1500 kg. Motor raises the lift at a constant speed through a distance of 20 meters. How long does it take? Okay, so power is equal to Fv or Fs over T. We need to find out T. So force or is basically 1500 times by 9.81. Displacement 20 divided by power 20 kilowatt, so 20,000. Okay, so 1500 times by 9.81 times by 20 divided by 20,000. This is 14.7, roughly 15 seconds. In which situation is the least amount of energy transferred? A student and a motorcycle, total mass 80 kg, come to a rest from a speed of 2 meters per second. A student of mass 50 kg falls a vertical distance of 2 meters. Student and a motorcycle of total mass come to rest from a speed of, okay, so the total change in kinetic energy would be half 80 v squared minus u squared, so v is 0, but this is 2 squared, so 40 times by 4, that is 160 joules. Student of mass kg falls vertical distance of 2 meters. Okay, we'll come back to that. There's going to be change in mgh, drop in energy. Okay, so the change in mgh, basically, that is going to be 50 times by 9.81 times by 2. So this loss in potential would be equal to change in kinetic. At the very least, this is 981. Okay. Student pushes a car with a horizontal force of 70 Newton for a horizontal distance of 2 meters. So 140 Newtons. Sorry, 140 Newton meter or joules. Joules, sorry, not Newton meter. Newton meter is moment. Student switches on a 70 watt lamp for 20 seconds. So 70 times by 20, that is 1400. Okay. So this would be part C. C. What is the definition of strain? Extension per unit cross-sectional area, no. Extension per unit length. Original length, yes, that is correct. A spring of unstretched length, 0.1 meters, is suspended vertically from a support. Weight of 2 newtons is attached to the bottom of the spring and its length increases to 0.15. Increases to, not by. So that means this is going to be an increase of, extension is going to be 0.05 meters, okay. An additional weight of 4 newtons is then added to the spring. Spring obeys Hooke's law. How much extra elastic potential energy stored in the spring due to the addition of 4 Newton weight. Okay, so we can do half Fx minus half Fx. Okay, so alright, so you can actually do this with the graph also, you can do this with algebra also. So Fx is, since it is obeying Hooke's law, so this is going to be a straight line. So when the force is 2 newtons, the extension is 0.05. Okay. An additional weight of 4 newtons. Okay, so an additional weight of 4 newtons would mean that the force has now gone to 6. So if we draw this further, we need to figure out how much additional energy, that means this part of the graph, how much this is. Right? Okay. Due to the addition of 4 Newton weight. Okay, so this is what we need to figure out, the area underneath that. Okay. So what we can do is first figure out what is the extension by this. So the ratio would be the same. As you can see, the gradient would be the same. So 0.05 over 2 equals to x over 6. So this would be 0.05 divided by 2 times by 6. X is 0.15. The extension becomes 1.5. And now we can figure out the area, because this is the area under the graph. So half times by 6 plus 2 times by 0.1. 1.5 minus 0.05, that is 0.1. So half times by 8, that means 4 times by 0.1, that is 0.4. Now, what if we decided to do this with the algebra? Let's see if we get the same answer or not. So basically half Fx minus half Fx. Okay, so you still need to find the extension, the previous of the next one. So since it is obeying Hooke's law, the gradient, the k, remains the same, right? The k remains the same. So k is equal to force over x. So if with 2 Newton force it was 0.05 extension, then with the addition of 4 Newton, that means 6 Newton, your extension would have followed the same relationship. So you see, you would have the same thing, 6 times by 0.05 divided by 2, you get 0.15. Okay, so half times by a force is now 6, extension 0.15 minus half, 2, 0.05. Now let's see, 0.5 brackets, because 1 over 2 is constant, 6 times by 0.15 minus 2 times by 0.05. So 0.4 is the answer, same as the graphical method. So 0.4. Two progressive waves meet at a fixed point P. The variation with time of the displacement of each wave at point P is shown. What is the phase difference between the two waves at point P? Okay. So phase difference is basically the path difference times by 360. And path difference, remember, that is just in terms of the wavelength. Okay, so the what fraction of the wavelength difference it is. Okay, so wavelength is 0.8. No, sorry, this is not wavelength, this is the time period. Okay, so we can do this, we can do the same thing with the time period also. So 0.8 is the time period, and the difference between them is 0.5. You see, this point and this point. Okay, so 0.5 over 0.8 times by 360. So 5 over 8, so 5 times by 360 divided by 8, that is 225. Okay, no, that means I made a mistake somewhere. Sorry, no. If you notice over here the same point, 0.1 and 0.4, so that is 0.3. Similarly, if you see the crest to crest, 0.3, 0.6, that is 0. Yeah, so basically that's it. Sorry, the difference is 0.3. So 0.3, that means 3. This is the 135 is the answer. Actually, the first one was also not incorrect entirely. So previously we had 0.5, like this point and the where this was, this one. So if we do this way, 0.8 times by 360, this comes out to be 225. But since there are no options, we can do 360 minus 225, and that would get us the same thing, 135. So you can check that out. 360 minus 225, you're getting 135 also. Alright, let's continue. A microphone is connected to the cathode ray oscilloscope. The diagram shows the waveform on the display of the CRO when the microphone detects a sound. Y gain is set to 1 volt per division and time base is set to 2 microseconds per division. Which row gives the amplitude and frequency of the waveform? Okay, so amplitude is the max minus min divided by 2. That means peak to peak divided by 2, simply. So you have 336 times by 1 volts divided by 2. So that means 3 volts. C6 volts is the peak to peak, but we need just amplitude. Peak to mean position. So 6, these two options are cancelled. Now we need the frequency. So if 1 division means 2 milliseconds, sorry, so this means this is the 4 milliseconds time period. So this is 4 milliseconds, that is 4 10 raised to the power minus 3. So frequency would be 1 over times, that is 10 cubed over 4, so 1000 divided by 4, 250. So B is the correct answer. A progressive longitudinal wave is traveling horizontally from left to right. The graphical representation of the wave at one instant in time is shown. Which row could give the correct labels for x-axis and the y-axis? It's a longitudinal wave, right? It's not a transverse wave, sorry. So the y-axis could give the displacement of particles to the right, but it cannot be upwards. Okay, so the upwards things we can cancel. Okay, so we need to figure out which one of them is the correct one. Displacement of particles to the right. Okay, one thing that if 1 instant in time is shown. Oh, sorry, they said that this is in 1 instant in time. Okay, alright. So that was my mistake. So this is not this is not the graph of displacement with time. It's just 1 instant. That means the time is frozen. So this is the distance with displacement. Okay. A vehicle is moving with the speed of 30 meters per second directly towards a stationary observer. Horn of the vehicle emits a sound of frequency 440 Hz. The speed of the sound in the air is 340. What is the frequency of sound heard by the observer? So Doppler effect formula. F naught is equal to V over V minus Vs. Minus because we need to increase this fraction. So 340 divided by 340 minus 30. Times by 340. Yeah, okay. Frequency 440. So 340 divided by 310 times by 440. This is 482.5, so this is 483. Oh, okay. Which row could describe the electromagnetic waves? There are transverse waves and speed is same for all wavelengths, so D is the correct one. A horizontal beam of light is incident normally on a polarizing filter. The incident light is vertically polarized and has an intensity of 24 watt per meter squared. The direction of the transmission of the axis of the filter is at an angle 30 degrees to the vertical. What is the intensity of the transmitted beam? Okay, so transmitted beam intensity I naught cos squared theta. So 24 times by cos of 30 whole squared. Cos of 30 is under root 3 over 2. So square would be 3 over 4. So 4 times by 6 is 24. 6 times by 3, 18. A pipe of length 100 centimeter is open at both ends. The loudspeaker is situated at one end of the pipe. Can emit sound of different wavelengths. Which wavelength can produce a stationary wave in the pipe? Which wavelength can produce a stationary wave in the pipe? Okay. That means we need to see the wavelengths, not just one. That means the minimum wavelength would be, minimum stationary wave would be like this. Actually, sorry, it would be in between, the node would be in between. Okay, so this is your antinode, this is your antinode, this is your node. So the difference, the length 100 centimeter is half the wavelength. So wavelength is just 200. Okay. So that means the frequency, fundamental frequency would be V over 200. Okay. So the next one would be, so we still have antinodes over here. So this would be, no, let's try again. Like this. Like this, okay? So you have 3 antinodes, 2 nodes. So you have antinode, 2 antinode, 2 antinode. So that means 2 times by half the wavelength, right? So this means the full wavelength. So full wavelength is now 100. So that means V over lambda now is V over 100. Okay, now you see over here that the difference between this and this harmonic is times by 2, right? So this is, in short, 2 times by frequency. That means the next one would be 3f0, and this one would be 4f0, this one would be, next one would be 5f0. Okay, so in short, the frequencies will be times by, the wavelengths will be divided by integer multiples. Okay, so 200 divided by 1, 2, 3, 4. Okay, so 200 divided by 2, 200 divided by 3, 200 divided by 4. Oh no, sorry, wait. Times by 2? Yeah, okay. Times by 5, okay. So this is 100, we saw already. This one would be 66. 200 divided by 4 is 50. 200 divided by 5 is 20. No, sorry, 40. So in this we have 50. A student makes a sound at point R near the building. The second student standing at point S around the corner of the building hears the sound. The building is sorted structure and there are no other structures nearby. Which effect best explains how the student is able to hear the student at point R? So this is just bending of the sound wave due to diffraction. Red light of a single wavelength from a laser is incident on a double slit. Pattern of interference fringes is observed on a flat screen that is placed parallel to the double slit. Which change increases the separation of interference fringes? So this is AX over D. So basically X is your lambda D over A. So to increase this, we can increase the wavelength. Red is the highest one in the spectrum, so we cannot increase this further. We can decrease the slit spacing or increase the distance. So decrease the separation of the slits. That's it. Blue light has a wavelength that is smaller. Green light also has a smaller, because the red has the highest one of them. VIBGYOR, highest wavelength in the visible spectrum. An electromagnetic wave is incident normally on a diffraction grating. Second order maximum is produced at an angle of 30 degrees to the direction of the incident line. The grating has 5,000 lines per centimeter. What is the wavelength of the wave? Okay, so basically we need first D. So this is per 1 centimeter. You have 5,000. So you have 1 divided by 500,000. This is in standard form we can write it as 1, 2, 3, 4, 5, 6 meters. Okay, now n lambda is equal to d sine theta. A second order maximum wavelength 2 10 raised to power minus 6, and sine 30 degrees is 1 over 2. So 2 and 2 over here get cancelled, so lambda is 1 10 raised to power minus 6. C. No, sorry, so 1 over 2 times by 10 raised to power 6. So that means 0.5 10 raised to power minus 6. So when you multiply this by 10, you further multiply this by minus 1. So this becomes 5 10 raised to power minus 7. So B, sorry. Okay. The resistance of a lamp is 10 ohms and the potential difference across it is 6 volts. How many electrons pass through the lamp in a time of 24 hours? Okay. First off, we can find out the current. I is equal to V over R. That is 6 over 10. So that is 0.6 amps. And we know that I is equal to Q over T, sorry, my bad. So to find out the total charge, we can find out the I times by T. So 0.6 times by T is 24 hours, so 24 times by 3600. 0.6 times by 3600 times by 24. 51,840. Now we know that the charge is quantized, so Q is equal to NE. So N would be this charge, coulombs, divided by 1.6 10 raised to power minus 19. So this value divided by 1.6 times by 10 raised to power minus 19. So multiplied way, this would be that. So 3.24 10 raised to power 23. What is the equivalent of 1 volt? 1 joule per charge. 1 joule per 1 coulomb. That's it. Because Potential difference is energy per unit charge. The resistance of some electrical components may change with changing conditions. Which component's resistance increases? A filament lamp has the potential difference across it is as it increases. That would be correct. However, LDR as intensity of light incident on it increases, no, resistance decreases. Metallic conductor at constant temperature, as the current through it increases, no, So as the at constant temperature, so that means the resistance won't change, so resistance doesn't change. The thermistor as its temperature increases, so resistance decreases, so that means the A part was correct. And we also know the IV graph of that. Gold is sometimes used to make a very small connecting wires in electronic circuits. A particular gold wire has a length. This meter is a cross-sectional area. This gold has the resistivity of this. What is the resistance of the wire? Rho L over A. 2.3, 10 raised to power minus 8. Length is 2.5, 10 raised to power minus 3. Cross-sectional area 6.25, 10 raised to power minus 8. So 2.3 times by 2.5 divided by 6.25 times by 10 raised to power minus 8 minus 3 plus 8. So 1, 2, 3, 4. So 9.2, 10 raised to power minus 4. A cell of constant electromotive force and negligible internal resistance is separately connected into 4 different circuits. Which circuit does the power dissipated by the lamp stay the same as the variable resistor is adjusted? Wait a second. In which circuit does the power dissipated by the lamp stay the same as the variable resistor is adjusted? So power dissipated is basically the I squared R. So for example, this one would be I squared R differently. So we need to see where the change will be compensated. Where the change will be compensated. So, you see, for example, in the first one, they are connected in parallel to each other. That means current will always be divided in based on the resistance of the variable resistor. So if for example, the resistance is increased, the current through it will decrease, increasing the current in this one. Right? So it can be compensated. The current will balance itself out. They will not be equal, but the change in the current will be compensated. In B, if you increase the resistance, current in this would also decrease. That means this cannot be true. If you, okay, wait a second. In the C part, if you increase the current or decrease the current, the resistance of the entire circuit is changed. That means the current flowing through this thing will also change. Same will happen with this one. That if you increase the current flow through this would increase. Current flow through this would increase. That means the power dissipation does not stay the same. So the only one that makes sense is A, because if you increase the resistance in the variable resistor, current flowing through it would increase, but the current flowing through this thing would change. However, if you notice the V squared over R, because power dissipation is also equal to V squared over R, V is the same, R is the same, so the power dissipation by the lamp will stay the same. So this is correct. If you look at it from the perspective of V squared R, V is changing as you change the R over here, potential divider. Same case over here, potential division changes, potential division will change. So this is where the potential stays the same. Okay. Sum of electrical currents into a point in the current is equal to sum of the currents out of the point, which is correct. This is Kirchhoff's first law. That means second law statements will be crossed. which results from the conservation of charge. This is correct. Conservation of energy, that is the Kirchhoff's second law. A battery of electromotive force 6 volts and negligible internal resistance is connected to 3 resistors as shown. What is the current in the battery? Okay, so 60, 1 over 60 plus 1 over R becomes 60 plus R divided by 60R. So this is the effective resistance of this one would be 60R over 60 plus R. Okay. So the net resistance would be 60R over 60 plus R plus 30, and if you times this by 0.12 times by 60R over 60 plus R plus 30 times by 0.12 times by equals to 6. Alright, so we need R. So 6 times 6 minus 30 times by 0.12, that is 2.4. And the left side is 0.12 times by 60, 7.2 R divided by 60 plus R. So now we isolate the R, make subject R. 7.2 R is equal to 2.4 times by 60, 144 plus 2.4 R. So that means 7.2 minus 2.4 R, that is 4.8. R is equal to 144. R is 144 divided by 4.8, 30. A potentiometer circuit may be used to determine the unknown electromotive force EMF E of the cell. Circuit diagram should include the battery of known EMF and negligible internal resistance, a uniform resistance wire XY, and a galvanometer. Wait a second. Which circuit shows a suitable arrangement for determining E? Okay, so the galvanometer has to be in the branch with the unknown EMF. So that means where it's outside, they will be not be considered. Okay. So the direction of the EMF, unknown EMF and known EMF, they have to be in similar direction. So if this is positive polarity, this is negative polarity, this is positive, this is negative, this is going to be correct one. The polarity setting, the polarity configuration has to be similar. So 36. Otherwise they will just simply add up. The EMF will just simply add up. The uranium atom of with charge plus 2e and nucleon number of 235 and proton number of 92. E is the elementary charge. What is the total number of protons, neutrons, and electrons in this charged atoms? Okay. So proton number is this. That means the electron number is also 92, and proton number. So nucleon number already includes the neutrons and protons, so we just need to add the 92 over here. Okay, no, uranium atom. Okay, so this is not uranium nucleus, but this is charge of plus 2e. That means 2 less electrons. Right, so 90. So we need to add 235 plus 90. That is 325. A nucleus W of a radioactive sample emits a beta negative particle and forms a nucleus X. Nucleus X emits an alpha particle to form a nucleus Y. Nucleus Y emits a beta negative to form a nucleus Z. Okay, let's first track the changes. So if W is a Z, this becomes nucleus X with A remains the same, but proton number increases by 1, because in beta negative a neutron becomes a proton. Then it becomes Y with alpha particles, so A minus 4, Z minus 1, 2, so basically Z minus 1, Z plus 1 minus 2. And then nucleus Y emits a beta negative particle to form a nucleus Z. So A minus 4, but proton number would be the same as the original. Okay, so it's the nucleus of the same element with a smaller nucleon number. Because the proton number is the same, so it will be the atom of the same element, or nucleus of the same element. So nucleus of the same element and lower proton nucleon number. Which particle is not a lepton? Leptons are electron, tau, muon, and neutrinos. So this is a lepton, this is a lepton, this is a lepton, this is a hadron based on quarks. How many flavors, types of antiquark are there? Same amount of quarks. So 6 quarks, 6 antiquarks. Up, charm, top, down, strange, bottom. 6 flavors. And that's it for this paper. Hope you enjoyed this exam and explanations. If you like this video, give it a thumbs up, subscribe to our channel, and turn on the notifications for future updates. If you would like to study one-on-one with me to prepare for your upcoming May-June 2026 exams, feel free to reach out in the comments, or you can also reach us out on WhatsApp or email. The links are given below. You can access the link tree also. Until the next video, take care. Bye-bye.